All right. So I'm going to run a couple of notebooks. I guess I have two notebooks. You will find them in the GitHub repository. So if you have already downloaded the folder, the repository, you're good to go. They are here. Oh, no, they are not here. What's going on there? Yeah, they are here. And there is a README. So the README gives you a reference to where the stuff is coming from. These two are the notebooks. And the README has a bit of explanation about what's going on and a code snippet that we can also run in a terminal window. These are examples of the drifters package that I was telling you about. And the first thing I'm going to explain a little bit is the notebook framework. So you've already looked at Jupyter notebooks today. In fact, you've already tried them on your laptop and on this computer, cloud computer that Alex has set up. We're going to do something slightly different. We're going to use Pluto. So Pluto, you're here in a terminal window. You start Julia, and then you start Pluto this way. It's just a regular package, a regular, Julia package. Once it's installed, you do pluto.run and then parentheses, and this will start the Pluto server. So it should open a window like this in your web browser. Anybody is trying it? Anybody is struggling with that? Okay.
Just Pluto.run.
Yeah, Pluto.run with parentheses, with nothing in that. So we're going to start by creating a new notebook. Let me know when you are there, or if you want me to wait before. Good? Yeah? All right. So to create a new Pluto notebook, you click this plus button here. You see my screen, is it big enough? A bit bigger. So there is a button that says create a new notebook, and that's that. You should see a window like this, and in front of you, you have a code cell. So if you're here, you can start typing things. And I'm going to say something like this. Right, so that's just defining a variable, which is going to be equal to 2. And then I'm going to be something fun, which is, I'm trying to impress you here. So we get to 4. But the reason I'm doing this is to demonstrate something else. So if you're looking at the screen now, I'm going to change something in the cell that's at the bottom. And I'm going to make this a 2. You should look at the first line. It's going to react and update itself automatically. Did you see that? All right. So Pluto is a sort of a slightly different kind of notebook this way, where everything is reactive, meaning behind the scene, there is an algorithm that keeps track of what depends on what. And if you change something anywhere in the notebook, in this case the second line, and the first line happens to depend on that, it will just react. So that's one of the big differences compared to Jupyter notebooks, is this is, in fact, a very strict linear program. You cannot go back and forth and, rerun a cell and so it's all very strictly tied up together.
Just wondering, do you know the reason why Pluto insists on putting the output before the input?
I'm not sure, no. But, we can fix that. Yeah. I found it kind of nice that way, yeah. So you know, typically, often we close down the cell, so you don't actually see the code, right? So here maybe I want to know what's going on, and I'm going to open the cell, and then it pops up down underneath, as opposed to above, which would push potentially the whole number down, right? I don't know. I've never really occurred to me. Yeah, so you can typically close the cells and hide them, which I believe you can do in Jupyter as well. And so just to hammer the point home. Okay, so that's the big difference number one between Pluto notebooks and Jupyter notebooks. Who knows what difference, major difference number two is? Any takers on that? All right. Well, the big difference is, in my opinion, that it contains your environment. Meaning that if you start adding packages, they're all documented in the notebook, in the file itself. Which means you can then do something like this. Oops, well, something like this, where I'm going to go and find my notebook that I had earlier. Okay? So this is such a notebook. It's a more complicated one. That's the text version of the notebook without being rendered by the server. What you see is code, okay? And then, eventually, pretty soon, you have that. And so that tells you which packages are being used. This is too small, so I'm going to make it bigger. So in this particular notebook, we are using Kairomaki for plotting, the Drifters GL package for tracking particles, and Pluto UI, which is to build widgets and interact. So as a result of this, because everything is kind of self-documenting, Pluto lets you do something like this. Well, I'm copying the URL of the notebook. I come back here, okay? And we're going to look at a new one. Instead of creating a new one here, I'm going to paste the URL here. And just hit open. By default, it's not going to run, so you have to tell it to run. But now what happens is the Pluto server realizes, and so just if you follow, because this is going to take a minute, try and do the same thing I just did. So you go here and you take this one that is called idealized vortex, right? You click on it once. That should be enough. You click on row. You take this URL. You go back like I did in the Pluto notebook interface. You click on these three dots to get back to the menu, and you paste it here. So once you have done that, what happens is, anybody wants to ask a question or me to pause at this point? Okay. So you're noticing here, I'm going to go back to full screen. You're noticing here at the top, over there, right here, there's this progress bar that's going to go and increase. As long as that's going on, you cannot really interact with the notebook. You have to wait for it to complete. And that is the reason, in fact, why it doesn't run by default, is because sometimes you have to wait a while. But what is going on now is quite useful. It's starting with, okay, I have a using packages, so I'm going to download the packages that I need. I'm going to install them into Julia. I'm going to pre-compile them and make them available. So that's typically the first thing that happens, and this is what you're looking at here in this line. You see that there's this little thing that says rotating. So that is my packages being installed and getting compiled. So it's the same operation we were doing before, but except it happens automatically, because now Pluto understands that the calculation depends on those packages. Once this part is done, then the code will execute in the order that the dependency analysis tells it to. And by the end of this, we should see the end result, which would be a plot that will appear here in the bottom part. So it should not take too long. It has now compiled the packages, as you see with the check mark. Do you see the check marks? There's check marks next to the packages. And so now it's moved on to the next part of the program. And now I can sort of tell you a little bit about what's going to happen. So the way that the drifters GL package works is that you provide flow fields, and then we're going to calculate, we're going to put particles in it, and we're going to let the ODE solver give us trajectories of those particles. So it's going to time step in time. This line here is how you define the flow fields. More specifically, you put them in a data structure that then will allow the rest to be very sort of automated. The flow fields in this case are very idealized. It's a solid body rotation, where everything just rotates. I believe there's also a convergent component such that it would go towards the middle of this rotating body. And then there is a downward component such that eventually you should see this. Oops. Oh, it's not here. Okay. So again, example. This. It's going to look like that. This kind of, idealized vortex of sorts. Oops, sorry. Going back. Oh, it's still going. What's going on there? This is surprisingly slow. Maybe I have too many of those running. Or maybe it's the ODE solver that just takes forever to compile. It cannot be my software, I thought it was going to be faster than that, though. Let me check something. Oh, I think I know what's going on. Okay, fair enough. Okay, I understand what's going on my side. Has anybody gotten further than I am? You have? Yes. Okay, cool. Oh, there we go, finally. The reason it's slow on my laptop is I normally use 1.11. For the previous demo, I used 1.10. So all of those things I ended up not having. So it had to recompile everything. Now it's completed. So, yay! So that's kind of it for this particular notebook. Clearly, I had an issue with the compiling. Ooh. I'm going to go back to 1.11 in a second for the second one. But before I go there, let me just illustrate a little bit what's going on. So U is just an array, right? So that's just an array that is specified as the flow field for one component, and then there's a V. They are assumed at that point to be orthogonal, and there's a W, which again is assumed to be orthogonal. With those three things, we have a three-dimensional flow field, clearly, and we can proceed. I want to delete this. Okay. So once we have this data structure of flow fields, the rest sort of follows naturally. This is the definition of the initial conditions, so where we are releasing the particles in the flow field. In this case, I'm putting the initial one single particle at a point in like a third in all of the direction of the domain. With my flow fields F and my initial positions, I can now define a new data structure that is called individuals. And these are the actual particles. Once you're there, what is this doing? Okay, I'm going to skip on that. I don't really have time for this. You end up defining a time period. In this instance, the flow field is stationary, so I can pick whatever I want. And then that formula here, integral bang IT, is the code to integrate. Is anybody surprised by the form of this code? Or is that familiar with everybody? The Unicode aspect of it? Okay, maybe nobody is, maybe that's natural to everybody to use Unicode, but for me, until I used Julia, I didn't know that you could write code this way. So Julia has Unicode support, which I don't think we have really encountered yet in this today. So this ultimately is just an alias for a function that would have like a regular name. But that's one of the nice things with Julia is you can actually write it in a way that, this is the way I would write it in terms of math, right? It's just an integral over time of this trajectory calculation. So this is all that I'm going to say about this one. Is there any question or comments? Anybody got this plot? You got the plot? Yeah, it worked? That is possible. Can I? It could also be what I sent myself, which takes a minute to compile. No, I think it's just downloaded. So you might not have to function. Yeah, so the internet, there's two networks where there's a special one that we have, and I don't think that's the one we're using. The other one that this one should work, that's actually one. So maybe you'll let me check which one I use. So the one I'm using is this one. The hotel Wi-Fi guest. Okay. We'll try that. I'm going to go to my favorite website. Ah, it works. Out of curiosity, is everybody on Blue Sky these days? No? Oh, wow. Huh? Okay, fair enough. I'm on both, but Blue Sky is really nice. If you're tired of Twitter/X, that's the place to go. That's where everybody that I know and have ever followed kind of has migrated. Is the non-fascist version of Twitter. Okay, so yeah, if you can't download anything, that's going to be tricky, especially because the next one would take more time downloading. So I'm going to do something myself, which you don't necessarily have to do, but I'm going to go back to a different version of Pluto. I'm going to kill that. So to turn off Pluto as a, what you do is you go back to your terminal window. you're here, this is still running Pluto, you do Control C, right? No? What's going on there? Well, okay. Okay, that's fine. Well, maybe you don't. No, I was using 1.11, and I think that's what I would use. The fact is my notebooks probably have the dependencies in them that are for 1.11. So it should go faster if you use 1.11.
I'm getting a problem with the statistics plan.
You are? Huh. So I'm going to go back to this one. Okay, well, that's interesting. Okay. Okay, I did something really bad to my laptop. Okay, so this one did work. So I'm fixing something here on my laptop. So Jesus. Okay, I just had way too many. Okay, I think I need to reboot my laptop at this point. I don't know if there's an issue, but I was running 1.10 and 1.11 at the same time. Anybody knows if that can create some trouble? Because I think that's what happened, is I was running a bunch of things together and so I'm sort of stuck. Well, maybe that means that it's a good time to start. The other notebook that you will find there, I will just tell you what it is. And hopefully it will work fine with a reasonable amount of Wi-Fi. This one is going to do a simulation of the Gulf Stream, and you will be able to interact with it and change a couple things. So please give it a try. We can look at it tomorrow if somebody wants to do that. Yeah, maybe let's adjourn. Thank you. Sorry for the slight mess.